after we go through your, we're not physically going anywhere. No. We are not. Okay, a combination, the big deal here is that permutations, I said order matters, but really I guess also not order, but also if you're assigning it a title. So I'm going to write that on the side. For instance, if I just wanted to send, I think I used this example yesterday, if I just wanted to take from my group and send 3 people to the office, it doesn't matter, like just 3, they're just all 3 going. Or if I'm awarding 3 scholarships and they're exactly the same, they're just $3,000 scholarships, okay? That's not assigning things a title. What I mean by assigning a title is, let's say instead I say something like, I want to know, I'm going to assign a president, vice president, and secretary, then let's say I chose U3. If I chose U3, I have to count it differently for all the different ways that you could be president, vice president, and secretary. Whereas if I just said, hey, I need U3 to just go to the office and grab me some books, then you mean that's U3, I just count it once. So the last scenario is called a combination, unordered arrangements, or if you want to think of it, unassigned. You're not assigned a title or a specific job. So the rule well, first of all, there's no thing like this, because there's only one way to do one combination, if that makes sense. If I said, hey, I got 10 of you and I want to send 10 to the office, there's only one way to do that, because I'm not counting your orders. So there's no like factorial just for a total of combinations. You're only going to see something like this, where I'm going to have a group and I'm going to choose like a smaller amount to send or assign. So n combinations take an hour a time, kind of like before we use the subscript notation. Or another way of thinking of this is n is the number of items in my set and r is the number of items I'm choosing. Just like before, I'm going to show you a formula, but I'm going to also show you where you can use your calculator to do combinations. Okay. As a whole, because you're not counting the different orders as separate cases, there's less combinations than permutations. So the formula looks like this. NCR equals, there's still an n factorial, like we had on top, up here. So you're still going to see that. And there's still an n minus r factorial. But then you're also going to divide off r factorial. So what's the difference between these two formulas? Yeah, so like if you knew what the permutations was and you wanted the combinations, instead of going all the way back to the beginning, you could just divide by r factorial. Okay, here's an example. If the Miss America pageant, in the Miss America pageant, 51 contestants must be narrowed down to 10 finalists. I'm not counting, this isn't the finals, I'm not counting their orders, I just need 10 finalists. They're unassigned, this is a combination. I have 51, and I want 10. Now don't get confused by this, because sometimes people will say, well, you said how many possible ways? Yeah, I did. That doesn't mean order matters. I'm just asking you to count the ways. Okay, so it's still a combination. It would be 51, C10. So the long way of doing this would be 51 factorial divided by, what's 51 minus 10?
41.
And then I'd also have to divide by 10. Let's get out our calculators. I think, where is my yellow guy? I had a student who used to borrow this and they call it the bumblebee. Get it?
Yep.
It's like a name, the bumblebee. All right, so if you're going to do it the long way, the factorial key is under the math menu. Remember this? 51 math 4. Whoa. And then if I was going to do these together, I'd have to do 41 math 4 and 10. I'm just doing it in the same spot. What's going on over there? There's a lot of talking. Uh-oh. Did you still get that many?
What? Why is it different?
It is? I just divided them. If you do a combination, it's just because there's that many, I guess. If I did a combination, I would type the 51. Okay. Do you see how I get the same answer? Mm-hmm. Do you remember what this means? That's scientific notation times 10 to the 10th. So a real lot. That is a lot. Imagine if they were permutations, it would be even more. It's because there's 10. It's a large amount of things that I'm choosing. Do we want to do another example like that? Do you think you get that? There was a question on your homework about a scholarship, I think, or not? Was that not this? Oh, 7 we didn't do because there was 6. I want to talk about 6 a sec. This is from your homework. We're still doing subset. 6 is not a combination. Can somebody tell me why 6 is not a combination? You did 6 yesterday. You're supposed to.
Because there's four specific scholarships.
Because my 4 scholarships are different. They're assigned different things. Okay. There's a 1,500 one, a 1,800. So when I pick from those 20 students, I have to count all differently if I assign those 4 different people to a different scholarship. If I was giving 4 identical scholarships instead, that would be a combination instead. Does that make sense? Mm-hmm. Okay. I also asked you to skip 7. Let's do it a second though. So at a Chinese restaurant, you have 48 main dishes. A group of friends decides to order 6 different dishes. This problem can be solved using combinations. Why? The order in which we're not picking, like it's just 6 dishes. The order in which you pick them would still be the same 6 dishes. Does that make sense?
Yeah.
Like it doesn't matter if you pick the orange chicken first or the cashew chicken first, you're still getting both of them. So there are 48 things chosen 6 at a time, or you're choosing groups of 6, and how many ways that can happen.
I'll show you how I arrived at that. Okay, so that's how I arrived at that number. Okay, the last thing we're going to talk about is, I think this is an interesting problem. We used to do the Wendy's thing because Wendy's used to, no, I know you go, oh my gosh, no. Wendy's used to have this thing, this advertisement a really long time ago, and they'd be like, you can get, and it was this large number of your burger, X number of ways, okay? And so then it was like, whoa, how did they, that sounds like they have all these toppings, right? Okay. No, yeah. So let me talk about a entire subset. So an entire subset with a combination would be basically how many different, like, I'm trying to say a subset, it's just a subset, it's a set under a set. If I had 8 total items, it is all of the different kinds of groups I could make, okay? For instance, if I had 8 items, I could make a group of just one thing. Out of 8, I could choose 2 things. Out of 8, I could choose 3 things, okay? All the way up to 8 things. So for a subset, I'll say, okay, an entire subset, I would add all those ways together. Dot, 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 dot. There's an interesting shortcut which I hope that we are able to get to, and it ties into this really cool thing called Pascal's triangle, and I hope that next week we'll be able to talk about it. We will. Because if you wanted to take a shortcut to this, you actually, if you had the entire subset, it ends up being just 2 to the nth power.
Where's 2 come from?
You're gonna have to wait. It has to do with when you add all these formulas together and then you get a common denominator, and I'll let you think about that a little more. Maybe you can prove it for me. Pizza place off, I actually need to add something. My fault. This is very important. Would you add a 0 to the front? There does need to be an NC 0 in the front.
Why?
Because it's possible, you're going to see in a second,
No toppings.
no toppings. It's possible.
Plain.
Okay. My example is a pizza place offers 8 different toppings. How many pizzas can be ordered? Well, you can get a pizza with no toppings. Well, maybe
Does that include cheese?
it would probably depend on the pizza place, but maybe the pizza place would say they, in their list of toppings, extra cheese would be considered a topping. So let's assume maybe the pizza comes with cheese, okay? If you want to assume you can order a pizza with no cheese, I'm sure they would be accommodating. But then you could, all of the different ways you could get 1 topping pizzas would be this. And then all the ways you could get 2 topping pizzas would be this. And then I will tell you this, they're just kind of thinking about this logically, the only way you could get no toppings would be one way. This is going to be a 1. And the only way you could get 8 toppings if you're using all of them is one way. So this is going to be a 1 too. Let's just look at these numbers. We already know, though, I told you what should it add up to be. 2 to the 8th power. But I want you to see some of these. Would you, just for the heck of it, so you can kind of know what numbers combinations are going to produce, what's 8C0?
you gonna type all the same numbers?
No, I'm gonna just have you do two of them. This is 1. What's 8C1? Eight. NC1 is always N, and NC0 is always 1. No. What is it? I don't even know that one off the top of my head. What is it? 28. Okay, let's go dot, dot, dot. I just want to point out to you, can you guys calculate 8C7 for me? Interesting, it's 8. And what's 8C8? Okay. Why are 8C0 and 8C8 the same thing? Can you go back and think of the formula? Why is NC0 going to always equal NCN? Do you remember what the formula was? Okay. This is the formula for a combination. Okay. So this would be n factorial over n minus 0 factorial. Okay. Over 0 factorial, and hopefully this brings up a 0 factorial is not 0, it's 1. Okay. And those both things equal 1. Same thing with NC1 and NCN minus 1, I guess, if you would. Because when you subtract the number, it gives you the R. So those just flip the places. These two things flip places in those formulas, so they end up giving you the same result. Something interesting. That's true of all combinations. What does it end up being, though, for going back to above? What's 2 to the 8th?
256.
So there are 256 different pizzas.